So now let's assume that we use this as reference node. Okay. Again, we have two essential nodes. This is node number 1, and we have this as node number 2 now. Okay. So the voltage here is V1, and the voltage here is V2. So writing the node equations for node number 1, we have now the node voltage here is V1 minus 20 and minus V2 divided by 2 plus V1 minus V2 divided by 20. V1 minus V2 divided by 20 and plus V1 divided by 5 ohm equal to 0. Okay. Now applying the node voltage method at node number 2. So at node 2. So look at here at node 2. So V2 plus 20 minus V1. You see the symbols, plus minus the signs. So V2 plus 20 minus V1. So we can write V2 plus 20 minus V1 divided by 2 plus V2 minus V1 divided by 20. V2 minus V1 divided by 20 and V2 divided by 10 plus V2 plus 85 divided by 2. Okay. V2 plus 85 divided by 2 equal to 0. We have now this expression. Okay. Simplifying this expression and simplifying this expression. So first we let's say it is equation number 1. It is equation number 2. And what about I5? I5 is nothing here, but it will be equal to V1 divided by 5 because it is a reference node. Okay. So just considering the first equation, I first remove this one and playing with the first equation for a little bit time. So simplifying this, we have 0.75 V1 minus 0.55 V2 is equal to 10. Okay, so I simply write this as equation number 4, because it is equation number 3, and the first one equation number 1 and equation number 2. And similarly, with this equation, V2 minus V1 plus 20 divided by 2 plus V2 1 over 10 plus 1 over 2 plus 4 I5 equal to 0. So here we have V2 plus 85 divided by 2. So V2 divided by 2, 85 divided by 2. So 85 divided by 2 is 45, and V2 divided by 2 is just added here. And similarly, substituting the value of I5 over here, so we have now so finally we have expression as 0.25 V1 plus 1.15 V2 is equal to minus 10. So simply equation number 5 here is okay. So from 3 and 4, we have, from 4 and 5, we have V1 and V2. So V1 is equal to 6 volt and V2 is equal to minus 10 volt. Okay? And now I phi is equal to, from here, I phi is equal to 6 by 5 ampere. Okay? Or you can say 1.2 ampere. So it is equal to 1.2 ampere. Okay? So now again, here we have the power dissipated in 5 ohm resistance square R. So 1.2 square multiplied by 5, that is 7.2 watt. So you see, the power dissipated is exactly the same as in the first method. So this just show you that there is no difference if you consider or if you want to change the reference node, the one which is already solved in the examples in the book. So it's up to you, up to your own test, whichever node you want to consider as a reference node. Final calculation should be the same, and of course it will be the same. So there should be no change. Okay. So next we consider another special case, and that special case is that if there is a voltage source between two essential nodes, and the important point is that one reference node, let's say that is a reference node. So if the voltage source is there in a circuit between two essential nodes, one is essential node and another is reference node. So what will happen to that problem? That will be the results will be more simplified, and we can easily solve the problem.